Hello and welcome to QED Stata 5 from S30. Let's try and merge these two data sets together. So we've had this in a previous session. First we've saved Madagascar file 1 and 2. You can do it the other way around if you want. I think it's going to be more convenient to open Madagascar 1 again. Oops. So that's the first file, all those binary variables, the yes/no variables. And because the second worksheet's got loads and loads of variables, it's got some of the same variables that have been taken across the binary variables, and it's got some other variables that are not so interesting. I think it's better to merge some of these, particularly the numeric variables, so like the amount of fresh food that people are short of, marine food people are short of, the total carbon stock and the mean carbon stock, bringing some of those quantity variables back and match them up with the binary variables. So it's the same command as before, merge 1 to 1, plus code, that's the variable that has to be the same in the two data sets. So I'm matching it on that. So I'm going to use this plus code to match. You could use the KBA name to match as well, but then if there's any slight spelling mistake, it wouldn't match up. But fortunately, I've got a code which is the same variable with the same name in both data sets, so we can use this to match up with. So that's the variable we're matching with, using, and this has got to be the right address to the data file 2, because we've loaded data file 1. That's the so-called master file in memory. This is the one that's coming in from the file Madagascar 2. Gen match report is just a funny name for the variable that's going to say how the match went. Keep match master means it only finds things that are matching in both files, and it won't. Sorry, it brings in stuff. It only brings in stuff from the using file that already exists in the match file. Doesn't add any more rows on, but it won't get rid of any rows in the master file if there are no matches. But in fact, it matches up nicely because we have the exact codes. And then keep using is just all the variables you want to bring in. So instead of bringing everything in, I'm just bringing in these areas. I've just listed them out here. So with any luck, I've already opened that. I can just do this, and it should give us a merry greasing with no red ink. Seems pretty good. Not matched 0, matched 221. Match report 3, which is the code for saying it all went well. In the data editor, then we should have a whole long. Yes, there's the binary stuff, the yes, no, yes, no's, and here's some numbers. So that's quite a nice format for making some comparisons. Yeah. Okay. I think to cut a long story short, there's one final thing I'm going to do. I noticed looking at the variables that I think that in many cases, so we can find a good example. So it's like the irrigation water, for example, here. Is that one? Yeah, for example, here. So this is fresh food insecurity. So one is these are households with there are households within a certain distance of this nature reserve who have got of this fresh water reserve who have got food insecurity, and this shows the mean food intake for that household availability in that household area. So it's if there's food insecurity, what is the level of food insecurity? So when there's 0, it should show -99. But here, these zeros here is 0 there. So this is showing that these households have got a 0 average food intake, which is just nonsense. So these here they should be coded as -99. I think in all these cases, these should be 99s, but these zeros here should be -99s. Otherwise, the analysis is going to be wrong. So I think in those variables, we need to replace the zeros with -9, well, with missing values. Otherwise, it's not going to be the analysis will be completely skewed. You could read through the paper and find the evidence of that, but I think that's the case. The coding's slightly wrong there. So we'll go back to the do file and just add a line to try and do that. We can borrow a thing from up here to do it with. Oops. So we're going to just take this, and we'll assume that they've got the same, they should be the same as minus 19, so we'll code them to the same value. But unfortunately, we can't use this exactly as it is, because if we look at the data file, there's lots of, in all these cases, all the no's are coded 0, they're meant to be 0. So if we code those minus 19s, they'll be completely mess up these variables. So there's nothing for it but to actually manually specify these variables here. And I like to do it by using this kind of cheat from the command line. Should go to the command line, wherever that is. And we can look up here a list of variables. So area, I mean, area shouldn't have any zeros. Let's leave that there. So this shouldn't have any zeros. This shouldn't have any zeros. This shouldn't have any zeros. None of these should have any zeros. And what you can do is you double click this, you get a nice, they pop up. Yeah, okay, that's what I think. So that's just a way of getting a list of variables. And then we have to go out to the definers and put that list in har. So in all those lists there, it's going to recode more known missing value should be 0. So it's going to code any zeros in all those variables. It should code as .a. Alternatively, it'll give us a huge error message, and it's quite happy with that. I didn't make any mistakes. Good. There you go. So you can see it's got rid of these missing values. Excellent. So I think that's really coded. So we've merged it together, saved it as well. Oh, we haven't saved it yet. Now you've got data in the form that's ready for analysis. All we need to do is to save that. So let's kind of just reuse that code there. Come down here. Merge data. Save it. There it is. So that's saved. So now we can use that again whenever we want. We're ready to carry on with some analysis, but we'll save that for the last video. And for now, thanks for watching.